We're doing example 4.1 about Newton's second law. An airboat with a mass of 3.50 times 10 to the second kilograms, that's just 350 kilograms, including the passenger, has an engine that produces a net horizontal force. Has an engine that produces a net horizontal force of 770 newtons. After accounting for forces of resistance. So this is going to be the force of the engine plus the force of the water or whatever. Okay, find the acceleration of the airboat. So we're going to do acceleration equals 770 divided by 350. Unit-wise, the 770 has units of newtons, which another way of writing it is kilogram meters per second squared divided by kilograms, and the kilograms cancel out, and we have exactly 2.2 meters per second squared. Now, starting from rest, how long does it take the airboat to reach a speed of 12 meters per second? For that, we'll use delta t equals delta v over a, which is going to be 12 over 2.2 meters per second divided by meters per second squared. The seconds comes up to the top, and we get 4.45 seconds. Part C says after reaching that speed, the pilot turns off the engine and drifts to a stop over a distance of 50 meters. With that information, we were at 12 meters per second. We came to a stop, 0 meters per second. In a distance of meters, we can calculate what the acceleration must have been. And there's only one applied force here, the force of the water resisting. So I'll call that force of resistance is going to be the mass times acceleration, because this is, in this case, it is the sum, but there's only one force applied. So in this particular case, the resistant force is equal to the sum of forces. So we'll calculate our acceleration from v final squared minus v initial squared divided by 2 times the delta x, and we get negative 1.44 meters per second squared. So that means that where we had the velocity in the forward direction, this is slowing it down. So we take the resisting force is equal to the mass of the boat times the acceleration of the boat, which is 350 kilograms, times the negative 1.44 meters per second squared we just calculated, and we get negative 504 kilogram meters per second squared, or 504 newtons, in the slowing direction, or in the backward direction of the boat. Question 4.1. What other forces act on the airboat? Describe them. The other forces, besides the force of the engine pushing it forward and the force of the water resisting its forward motion, are the gravitational force pushing the boat into the water, and I've been calling this the normal force pushing upward, but since we're in water, we're going to call it the buoyant force pushing upward on the boat. Example 4.2. Horses pulling a barge. Two horses are pulling a barge with mass 2,000 kilograms along a canal as shown in figure 4.7. The cable connected to the first horse makes an angle of theta 1 equals 30.0 degrees with respect to the direction of the canal, while the cable connected to the second horse makes an angle of theta 2 equals negative 45.0 degrees. Find the initial acceleration of the barge starting at rest if each horse exerts a magnitude of 600 newtons on the barge. We want to ignore forces of resistance on the barge. So our objective here is to find the acceleration, which is the net force divided by the mass. So the net force is going to be equal to, let's call it force 1 plus force 2. And force 1 is going to be F1 cosine theta 1, comma F1 sine theta 1. Because these are both measured counterclockwise, both of these angles are measured counterclockwise from the forward direction. We'll just use that description as theta is counterclockwise from forward, or left from forward. And this will be for F2 cosine theta 2, comma F2 sine theta 2. So plugging on numbers, this is 600 cosine 30, 600 sine 30, 600 cosine negative 45, and 600 sine negative 45. Which comes out 600 cosine 30 is 520, 600 sine 30 is 300, 600 cosine negative 45 is 424, and 600 sine of negative 45 is negative 424. And you'll notice that that sounds right because this is going to the right and up, and this one is going to the right and down. So that's why we have a negative number there. So our total values are 944 to the right and negative 124. So it's going a little bit, I'm sorry, 944 forward and 124 kind of pulling to the right, which is the negative y direction in the diagram. So I got a force with a magnitude of square root of 944 squared plus 124 squared at an angle of arctangent negative 124 over 944. So 952 newtons at 7.48 degrees. That would be clockwise from, so like this, oops, yeah, this direction here, 7.48 degrees this way. But we weren't asked in the end for the force, we were asked for the acceleration, which is going to have the same direction, but it's going to be the force divided by the mass, which will be 952 divided by 2,000 kilograms. So we have an acceleration of 0.476 meters per second squared at about 7.5 degrees clockwise from forward.